All right. We are maybe live.
Yeah.
We are definitely live on YouTube. I do not know if we are live.
I don't see
Oh no,
any.
we are live on Streamplace too.
Ah,
Let me just check. I don't see a post on Blue Sky, which it does say it'll do. And the preview looks very jittery
huh.
for Blue Sky on Streamplace. So that may just be looking like absolute shit.
Yeah. Don't know yet.
It says, we found a few things. Your stream contains B frames, which are not supported on Streamplace. I don't know what that means.
Yeah, it's something encoding from the H.264 codec. You have B frames and reference frames, something like this.
But that is not something I can configure through my streaming software. So the preview, though, of us talking is hilarious because it looks like stop motion.
Yeah. Yeah, no worries. We can figure this
I think
one
I'll
out
turn
later.
off Streamplace and save anyone the hassle, and we'll just keep this first one on YouTube. And what we'll do is we will try and resolve this for future.
Yes, definitely.
So I've turned off Streamplace. We are live on YouTube.
Yeah, nice.
And I'm going to see if I can set the live URL on Blue Sky with the new live indicator and see if that works. So, let's see. Go live. Linky link. Oh no, only supports Twitch and Streamplace. All right. It is what it is. Let's just make it work. So, we've never done this before, hence very ad hoc. So, to anyone who does tune in, welcome.
Hey.
This is what we are calling, I don't know if it's a code name or a go public name when we eventually get around to making this a bit more official and polished, but Chevron7, as we are both huge Stargate fans.
Oh, yes.
And we're using this as our, I wouldn't call it an office hours per se, but we are just being a bit more building publicly, showing what's happening behind the scenes of the Rawkode Academy. And I'll just leave it at that, and we'll do a quick introduction, and then what this first session will be, and then we'll take it from there. So if anyone does just want to say hello in the comments, please feel free. And if you like what we're building, let us know as well in the comments. We'd be happy to do more of these, that's for sure. In fact, we will be doing more of these, that is definitely for sure.
Yeah, definitely.
So hi, I'm David. You've seen my face many times over the last 7 or 8 years as I live stream everything that I'm doing cloud native. And this is more, as we said, behind the scenes of the Rawkode Academy. So I'm going to be showing you what I am doing to improve the website, new tooling, how I work, all of that. And I'm joined by my friend, Stefan,
Hey.
Puma from the Discord. You want to say hello and share whatever you wish to share?
Yeah. My name is Stefan, called Ice Puma in Discord and everywhere. I'm from Berlin, Germany. I'm helping David since, I guess, 5 years for building everything behind the scenes. And I took the opportunity to build something that I wanted to build for a long time. And it's a good thing to support the new clustered thing you are building right now. And I thought it would be cool to have like a playground for DevOps to sharpen their skills or to just tinker around with like VMs on their hosts. So I'm trying to build, or I'm building Intar. It's named after the training weapons from the SG universe. So you see the reference here. And it's basically based on QEMU. You get a scenario, let's say you have to configure or you have to reconfigure a broken Nginx. And the idea is that you have some gaming type of experience or gamified type of experience and see a progress, how good you are doing. And then, so the idea is to get better in DevOps type of things. And I built a CLI for it, and now I want to show it off and see how we can improve on that. It's like the first beta version. It works, but it can be improved in good or more ways. So, yeah.
All right, well, we start with your demo then?
Yes, definitely.
Awesome. All right, your screen is now live and broadcasting. Take it away, man.
Yeah, cool. So, I mean, it's published on GitHub. You can download the binaries, try it out by yourself. You can compile it by yourself and run it through Cargo. It's all based on Rust. The only prerequisites are some QEMU tools, but you can get this from the README. But I'm just showing off the workflow or the experience, what you would see if you would use it for trying out the scenarios. Or, for example, if you want to prepare for clustered, there will be more scenarios based on Kubernetes. I have one multi-node Kubernetes scenario you can try to fix. But I'm now showing off the Nginx scenario. And here, you just say start, you give it an HCL file. The HCL file, I show it off later, is just a bunch of instructions on how to set up the VM, like resource-wise, and how to destroy or break the VM so people can fix it. And when you start, you get the nice mission briefing screen. The context, I mean, obviously there should be more information here. So it just says fix a misconfigured Nginx. But this should be Markdown, so we could render URLs or even images if your terminal can support it. But basically what I'm trying to show off here is you get the operation. It's the name of the scenario. Then the VM is booting behind the scenes. And here you see all the objectives you have to fulfill. And down here you can see the status of the VM, the whole booting thing. When the VM is fully booted, this will change and you get like a 3-tab screen. But I show it off as soon as this thing is booted. It takes about 1.5 minutes here on my machine. Depends on whatever I run in the background as well.
Why don't we take a look at the HCL while it boots up?
Yeah, sure. So here, I hope you can get a glimpse of what the HCL looks like because of all the broken new line stuff here. But I support multi-arc images, so you have to specify the image by itself, like the download link. When you don't have the image on your machine, it will download the image for you. You get like a nice progress bar. And it also does the checksum thing so that you don't download evil images. I mean, there's no guarantee that those images aren't evil, but some person has to figure out the SHA-SUM and put it in here to prepare it. And then you have the concept of probes. There is a small agent that I inject into the image, and then it starts as a systemd service. And this thing here polls for everything in the background and fills the information here into the probe screen. But I'm wondering why it takes so long to boot. Maybe I have to usually it should be up by now, but we can fix this in a second. And the probes that are like they look into the VM to see if the scenario is fixed somehow. And for the scenario to be fixed here is the service has to be running. the service has to listen on port 80, and the default site that comes along with a package when you install Nginx has to be enabled. And obviously, when you enable the page, it should listen on port 80, and then you can reload the daemon, and then Nginx should serve the thing on this port. And for the breakage, everything down here, you can have multiple steps. It will get translated into Cloud Init. So that's the thing. You set up the VM, and the rest is just Cloud Init. And here I say stop Nginx and delete the file to make those probes work. And down here, I reference the probes from the scenario here. So I can obviously have multiple VMs and say, for example, for 3 different VMs, I can have 3 different probes, and each VM just references one.
You do have another example, right, with K3S with multiple VMs?
Yes. There's a lot more of things here.
Yeah. There we go.
Yeah, and I have like 2 sets of probes. You have boot probes and scenario probes. I have to. I'm not really sure how to do the naming here. This could be like a key for the HCL. I mean, this one here. Right now, it just says face equals boot. And if you have like a boot probe, the whole screen here changes to the running thing only if you have all those boot probes running. And what it does right here is saying, okay, I'm expecting for all 3 nodes to be ready. Have like a TCP ping for the ports of the thing on the private network. There's also a thing I'm doing is setting up a private network, so all of those VMs can connect to each other. So there's one network interface for SSH and one network interface for, let's say, Kubernetes to bind to, so they can talk over the network.
Do you want to restart your entire run? Because I don't think that's going to happen. Because when we practiced this, it took 90 seconds, and it's now at 7 minutes. So.
Yeah. Give me a second. I want to check on my activity monitor if there is some QEMU running. No, it's not. I mean, I can try out one thing later. You can get the logs from the VM, like the console logs. You can get it from the inter-CLI. We can inspect it after this is not working again. But back to the HCL. For setting up things, I mean, obviously setting up Kubernetes is a bit harder than just stop the Nginx service. I'm not really sure if I should do like those pre-baked images to prepare like an image registry where people can download those images. But I wouldn't trust those images if I want to run, or if I were the person running those scenarios. So yeah, now it's running.
Yeah, much better.
Yeah. And I thought it would be easier to just have setting up the things and taking a bit longer. I mean, if you want to rerun the whole thing, you can just press restart, right? Yeah, and here is a bit more into, or there has to be some more work into, or you have to put into the scenarios to make them run for K3S. But I think we've talked about it, that clustered will be only single node Kubernetes, so setup will be much easier. This is like the multi-node thing.
Yeah, we've tried multi-node clustered in the past, and honestly, it's just not worth it because all the breaks need to be replicated across different nodes. The fixes have to be replicated across different nodes. And it just detracts from, in my opinion, the experience. So clustered, I think, will just always be single node. I think it just makes more sense. I mean, I could do one worker node and one control plane node, but
yeah, definitely.
I mean, you're as well just untainting the control plane node, and you get the same experience without any of the drawbacks. So
yeah, definitely. Yeah, cool.
I really like HCL as the interface for this. I think defining the probes and the steps and all that is just is declarative, which is nice, but it's also just, it reads well. I think it's a really nice choice for the way to configure these scenarios.
Yeah, definitely. And for the kubectl stuff, there is a way to just do kubectl apply. You can slam all the YAML in the world you want to have into the scenario. But I'm also thinking of modeling the whole like Kubernetes DSL into the thing where you can say, I want to have this service with those labels, with those annotations. So it's pretty easy to map all your YAML into HCL somehow. But that's something for later. Yeah, so right now we are in like the main experience of Intar for the CLI part. You see 3 different tabs. Explaining those tabs in a minute. And if you want to see what those key bindings down here are doing, you can press the question mark. You get like a small help menu. I've did it while we were talking. You can change the theme from dark to light and back and forth. What I'm currently doing is make one snapshot of the whole VMs at the beginning of the scenario run, and you can restart. So let's do this. It's doing some things behind the scenes, like restoring the snapshots. And if you move down the video avatars a bit lower, 1 second. Because there is the run timer next to the boot timer. Yeah, perfect. Here you can see the thing, and after resetting the scenario, we got a new timer. Yeah, and what you basically have to do is you have to SSH into the machine. Yeah, all the commands will be here in the future. But let's do this. So the VM is called web server, so we can SSH into it. Here you go. This is the VM. We're running through QEMU, and we want to fix all those probes. Let's say, okay, we want to fix the running Nginx. We could do this by calling sudo systeml status Nginx just to see what the status is. Okay, it stopped. So obviously the fix is starting it. And now the first probe passes. Nginx is running. Let's try to fix the next one. I mean, the second probe will come when we reload forgetting the words, the daemon, like the Nginx one. When we reload the thing, when we enable the site, but we can have a look into the site. Nginx, sites available, default. Here you can see it's running on port 80. So after enabling the site and reloading, the scenario should be fixed. Here is not working. Something.
And just the term needs set.
Yeah.
You need to do that later. You won't be able to do that live.
Yeah, no worries. Yeah, so the thing is, we want to symlink the thing from available to enabled. And we call it default here. And then you can see the second probe passes. So, I mean, I'm not sure on the intervals yet, but the thing is polling. I'm not sure right now, every n seconds to see if the probes are succeeding because of having like this near real-time experience. And yeah, So we've done the things to fix the linking, and now we just have to reload the Nginx thing here, and bam, the whole thing is fixed. And what I did is to have like a cinematic experience to show off the credits. I'm scrolling you through your log here. Oh, yeah, I forgot one thing to show off the tabs. But, I mean...
You have a snapshot.
we can restart, right. Yeah, so the thing is, I won't fix the whole scenario again. I just show off the things here. The thing is, when you want to use this for like training purposes, or I'm working behind the scenes on like a SaaS where this will be done in the browser. So I'm currently setting up a cloud infrastructure to spawn VMs, and then you will have a web terminal you can SSH into and do everything in the browser. And the transcript feature will be for, let's say, training purposes. You want to do like the hiring process through Intar. It will be pretty cool to show off what the people did inside the VM. And to show off that it works locally, we can just say echo lol. And you can see here it's mimicking the prompt here and says, okay, this is the input and this is the output of the things you see. And also if we say, for example, Nginx sites no available and default. I mean, we could also use cat. Then you also see not cool formatted, but you will see it here.
What if we open the file in Vim and make a modification?
It should be able to do this as well. I mean, obviously you can scroll through it if you want. Sudo vim nginx sites available. Default.
Just delete all the comments and then...
I mean, we can delete the whole file and just write it. I mean, you can see the Vim input and then just I think it's just the first thing the terminal sees through the PTY, like the first buffer, but you don't see every step of the things you did. But it's able to catch a lot of things here. And when you have like multiple VMs, you get like on all the systems where you see logs, you obviously have the VM name in front, and then you can do things. Yeah, but yeah, from the inputs here, you can follow on the things I did in Vim. I've used the D and then the big G, where you can delete just everything from here to the end, and yeah, pretty neat feature. Yeah, and on the third tab, you see every VM you're running, also the port. So for every run, I create just a pair of SSH keys, a public and a private one. And the public one gets injected into the cloud init, and then you can use the private one to SSH into it. One feature I can show off as well is the logs thing. You get the console logs here, but there is also a way to get more logs. I have to specify the VM at least. I'm not sure if I implemented the whole thing. So it auto detects the latest run. I'm not sure. VM not found. Maybe I have to specify the run. It's choice fireback 1649. Should be this one.
You forgot the logs command.
Ah, you're right. Yeah, okay. Now you can get all the logs. QEMO1 is empty. But then you should... yeah. So basically what I'm doing, this should be the user data. But what you're seeing right now is the whole base 64 representation of the entire agent that gets injected into the thing. Yeah, I'm not sure I'm doing it the correct way, but you should see the YAML that gets injected into the cloud init, but this will run forever. But just so I forgot that it got injected. I just remember. But yeah, so you're able to get the logs. You can do the inspection afterwards if something fails, if you want to test the whole thing. But yeah, that's basically it. It's a playground for DevOps to train their skills. I mean, I will rework the website, put out more scenarios. We will test the whole thing with a clustered preparation. And I think it will be a great thing. I mean, there are already things out there, platforms equal or similar to what I'm trying to build. There's SAT servers. There's Instruct.
Yep.
And there's other like
Eximius Labs.
Yeah, right. I think I forgot.
But Enter is open source. I mean, anyone can.
Yeah, it will be open source. I mean, the hosting will be, or the idea will be, there's the website. You should have an account, but you can bring your own hardware. So, for example, if a company wants to run Intar on their own, they just have to install the agent. It will be like a WebSocket type of thing, I guess, where the agent connects to the Intar platform. I get all the information, and then I can show what resources are available on the bare metal server. And then when people run the scenario, one VM gets started on the host, and then the SSH port and the some port that maps to HTTPS, they will get opened to the public, and then they can play around in the browser to see if everything works, and then they can SSH into the machine. And I mean, there will be a web terminal and the way to use your local config, and then you can use AI tooling to fix the scenario or do it manually, like you want. Yeah.
Very cool.
Yeah. Do you have something you want to talk about? I mean, you've done the Ralph Wiggum experiment lately for building something cool.
Yeah, I mean, I don't have a full-fledged demo or even code like you have. I think I'm using AI more and more for coding now. So what I want to do is I'll just show you how I'm doing this. And on top of that, it's like I have like a real job now. So I'm not able to spend my 9 to 5 actually building the stuff that I want to build anymore. So I'm now pretty much reliant on these AIs being autonomous and working while I am doing my real job. So with that being said, we'll share my screen. And I'll start with the V1. So target directory, blah, blah, blah. This is a Rust project called Rawkode. And I've used Ralph extensively over the last 3 months. And it has gotten me so far. But Ralph is on purpose stupid. And the answer to this, I'm not going to mention his name because he's doing the whole crypto thing now and I don't want to get into it. But the creator of Ralph his answer is just to run multiple Ralph loops for refactoring and planning and like reviewing. And it's honestly, that just doesn't give me the autonomy that I want from my AI agents. And I don't think we'll be doing Ralph in 3 months' time. I think Rawkode is going to come out with something that just changes it and everyone forgets Ralph exists. But right now, I can't wait for Rawkode to do this, or Codex, or anyone else. So I'm trying to do it myself. And one of the common things we're seeing right now is the adoption of ACP being pushed by the Z team and by agent SDKs. So my plan was, well, essentially what I need is a state machine, right? I need my agents to start with a planning phase, a development phase, testing phase, code review stage, and then be able to navigate those stages depending on some sort of arbiter, right? A project manager that sits there and goes, oh, this isn't good enough, we need to do this. And this is actually quite easily done. It doesn't even require a lot of code. And in fact, I had a Ralph loop build the initial version and then started using my own arbiter to build new versions. So we're in a phase now where this one was written in Rust using ACP, trying to do as much of it as that route as I could. But I ran into a lot of challenges and just didn't really felt that I got the developer experience that I wanted. I mean, we can even try and run it, right?
Yeah.
So if I run Rawkode, I can say agents, and I can see that I've got my arbiter, which is my project manager. We also have a planner, developer, debugger, reviewer. They're all using Gemini ACP because it's free, right? So great for testing.
One second.
And I could just,
sorry, can you see the screen? Because right now in the live preview, I just
So because I was moving our faces around a lot, I put it onto studio mode,
okay,
which means I have to approve changes, but I don't actually need to. I can't approve changes when I'm doing the demo, right?
Now it works.
Oh, so now you missed. You laughed when I said, "Oh, target directory." I started by running LT. Which
okay.
Which my LT, I don't think I have a get ignore here. So we have a Rust project. We can run agents. We have the arbiter, debugger, developer, planner, reviewer. But what's really cool is I can say run and then just say create rawkode.txt. This receives the task. The arbiter works out the best agent to run the task. The agent does it, then determines the task is complete, and then exits. The ACP I also found very, very slow, which is one of the other reasons that I stepped away from this approach. Now this is going to take 30 seconds just to get to the part where it delegates. I'm just going to control C it. I just decided we're not doing this. I want to do it a different way. And yesterday, we don't have anything beyond documentation right now. Because yesterday, Copilot announced their SDK. We have the Cloud Agent SDK. And I went, actually, this gives me the access to the multi-model evaluations that I want. Because I really want to use Opus 4.5. But I really like Codex 5.2. And I'm sure these models are going to continue to improve. Gemini 3 is okay. But I do want to be able to say this, I want to use Codex for code review, Opus for writing the code, Gemini for UI stuff, right? There are different modalities for each of these models that I want to be able to leverage. So Copilot SDK gives me access to Gemini and Codex. The Cloud Agent SDK gives me access to Opus. Now, because I can't really show you the new SDK approach because it doesn't exist yet, I can show you how I got to using Claude right now to get my documentation to where I want my documentation to be. So what we have are some ADRs. So I'm a big fan of Dino and Bun, but I am going to use Dino for this project because I do want to use maybe some of the sandboxing stuff that Dino provides. Particularly, I can, with the agent SDK, say you only have access to these tools, but I can actually enforce that with a Dino sandbox. So I thought I would go down this. We then have XState powering the state machine. We have the agent configuration. And all these specs, I think, are really important, right? Spec-driven development has become a really cool thing that we're seeing because agents can follow a spec. And if we can lead it down a path of formal verification, which we're so far away from right now, we can have proofs beyond just tests that our agent does what we want. So I wish I could show you Rawkode, but I can't. I only have specs. So instead, what we're going to do is create a new thing. And I'm just going to show you how I use Claude or any other agent right now to interview me to get to where I want to be. And then hopefully when we do this again next week, I'll be able to show you V1 of Rawkode because my agent will have built a V1 while I'm sleeping or working.
Yeah, this would be
So
cool.
we're going to spec out a new project over the next 10 minutes, and then we'll wrap up this session. We're already kind of 5 minutes over where we said we were going to be anyway.
Yeah.
So, all right, what do we want to build? How about we want to build something simple, right?
Like a dot file manager.
I mean, I've done that, but
Yeah, I mean,
I wish I'd used HCL for come try. Maybe I'd still be using it. Anyway, yeah, let's build a dot file manager, right? So, hello, I want to build a dot file manager in, I've done Rust before. Let's go with Swift. Let's just go rogue, right? Interview me until we agree on how this should be built. The output from this session should be a directory of ADRs and a directory of specifications. This is how I start all new projects with Claude. And eventually Rawkode will actually just do this by default.
Yeah.
So there will be an interactive mode. But right now, I just do it with Claude because I feel it is the best model. It was the first one to have the Ask Question tool, which really just makes plan mode and building specifications work. So we sit here, and I will caveat this with this will be a very brief interview session because we don't want to sit here for a long time. But I have had interview sessions with Codex and Claude that have been multi-hour affairs, like 3+ hours, just to build out the specs. And I really do believe that the code quality, having those specs, is 10x where I want it to be. Not only that, the reason I'm going down the agent SDKs and having the different state transitions is we need to be able to enforce code quality that we agree with. Like, I don't want to sit and babysit Claude Code, right? That's how we all do it right now. It's how and it just doesn't work. Like, I need to be able to have a reviewer agent that says these are our tenets of how we write code. Like, we want TDD, or we just want good test coverage. We want clean code. We want loads of traits when we're working in Rust. If we're working in Go, then we want to have proper error handling, or at least as good as we're going to get, and all these other things, right? So I'll say this is a personal dot file tool where everything lives in Git. It's cross-platform. Yes, different values per machines, etc. And it's going to take those answers, and then it's going to come back with more questions, and we just iterate and iterate and iterate. So I'll try and keep this as brief as we can.
Yeah, I tried the interview thing for the entire cloud hosting, and I'm not done yet because I'm using the max reasoning thing and also pour in some web research. So it's pretty cool. And I really wanted to use the Ralph Wiggum approach for building the cloud thing because I have never used it. So it's pretty cool to learn it from you.
Yeah, I mean, I just don't think the Ralph thing is going to work long term. Like, it does complete a task, which is what a lot of people want, and it does it autonomously, but without, the state transitions enforce the quality gates. Otherwise, you have to then run a Ralph Wiggum loop, go to sleep and have it build something, then run another one and tell it to refactor and clean it. But you don't really get the control that you need. And, code quality is very important, even with AIs writing it. So we want symlinks because I like to be able to modify a file and see it instantly change my application. I hate having to do any sort of run afterwards. We can go Swift native. We can have logics using Ginger 2 or Mustache. We'll use the Swift template and library. Secrets. Let's just do no secrets because we don't have time. And do we want lifecycle hooks? No, we're going to keep it very simple for now. I'm not going to let it ask too many more questions because I don't want us to just sit and watch Claude talk to me. So I'm just going to ask it to draft the first set of ADRs and specifications based on what we have now. I'm curious what a Swift DSL is going to look like, so let's just go with that. We'll do explicit mappings because I don't like the magics. We'll do subcommands. And we'll just do auto backup. And submit. Now it's got those answers, but I'm going to interrupt it and say, based on what we have now, draft ADRs and specs. And we'll just put it onto auto accept mode. And this is just, even just having the ADRs and the specs, I can then just kick off a Ralph loop or a Rawkode agent flow once I have it working, and then go to sleep, do my job, spend time with my kids, go to the pub with you, like whatever I want, right? So.
Yeah. Yeah, and also for let's say verification reasons, it's pretty cool to read up on those ADRs later if you want to know how the agent or what the basis of the reasoning for the agent is. And also for sharing information with your peers. So let's say we want to build something together. We sit down into like a mob interviewing session, and then like we do right now, but more focused. And then the outcome is that we all agree on the same architecture. And then we could split it into like more packages. So people could, or not the people, but the agents could work individually on those. That's a pretty cool approach.
I don't know why Zed's not working. Let's go with Helix. So what do we have? What directory am I in? That was weird. All right, so we have our Swift implementation ADR. Obviously, the ADRs are pretty minimal. They're just, here's the decision that we made. Oh, my thing is going nuts with files. We don't have any specs yet, do we? Just all ADRs. Oh, it's writing the first spec now. Okay, it's writing the code architecture. An example of how this works as well, if I show something that isn't really worth showing yet, is that I always have it, docs. So this is another project. This is building an XMPP compliant server. Now, the fact that we already have confirmation compliance tests out there that exist for XMPP is that I could just let a Ralph go nuts on this or a Rawkode and it'll build it. And I just have it keep a project management log where it ticks things off as it goes. So the agent on every loop decides what needs to work on next. So here we have like, subdomain support and more compliance tests. So I don't plan on this being the way that the Rawkode agent works.
Mm-hmm.
So if we come back here, if we go into our docs, one of the things I want it to be, the fact that we have this state machine means we can be a lot smarter about how the context is managed going forward. So we have 005, which is long-term memory, where we're actually going to have, after every state transition, there's a phase that runs where another LLM with a prompt, a system prompt, which is just the decision maker logger, whatever we want to call it, will look at all the output from the agent itself, determine if anything is worth storing as a long-term memory, and then store that as a markdown file. Where it's like, okay, we made some decisions on authentication. You should use this memory when we're working on security authentication, when we look at these code paths. We've got some taggings, importance, discovered by, and then it's just MDX. So it's like there's an actual, here's what was implemented, here's decisions that should be remembered. So trying to make sure that we only provide the correct context to each state or agent in relation to the task that it is working on. So it's just LLMs all the way down, essentially building this DAG and having it work out the right thing to do, like a human would try to do, right? We'd have project managers, developers, testers, QAs that all have different things that are important to them, and making sure we deliver that to the agent as it's building. And there we go. We now have specs and ADR. So this is how I start all projects. And hopefully, when we chat again next week, I'll have a working version of Rawkode to show you building something cool.
Yeah, and maybe I'm using it by then also. That would be pretty cool.
Fingers crossed.
Yeah. Was a cool first session, my first live stream ever. So thanks for having me. Yeah, and I'm looking forward to do this more often. And I'm happy to be part of the Rawkode Academy. And yeah, we have great things prepared for the Academy in the future.
Yeah, well, I mean, thank you for all your help over the years. I'm excited that we can do these things now on a regular cadence to show people what we're actually working on behind the scenes. I hope people enjoy it, and we will be back again next week. So I guess we'll see everyone then.
Yeah, bye.
Tschüss.